Hello, ladies and gentlemen. We're going to do a real quick intro to parallel and perpendicular lines and the main ideas that you need to understand for parallel and perpendicular lines. You have probably heard these words before when it says parallel lines are lines that never intersect. And when I say ever, I mean they never intersect. When you think of parallel lines, you probably think of something like this. These are two lines that do not ever intersect, and we're going to talk about why in a second. Perpendicular lines are lines that they do intersect, but it's not just that they intersect in a very special way. We're going to say at a right angle. They form a right angle, which if you don't remember what a right angle is, that's a 90-degree angle. Now you have to be very careful with both of these because sometimes the picture is not exactly what you think it should look like. So when I say right angle, a right angle forms a 90-degree angle. You guys have seen this symbol before. That means it's a 90-degree angle. Think of like the corner of a square. That's a right angle. So parallel lines never intersect, and perpendicular lines do intersect, but they intersect in a special way. And what's interesting is I can see I move this line along, it's still forming a right angle. So there's some different stuff going on with perpendicular. So what we're going to do is I have these 2 points or these two lines, and we're going to figure out the slopes of them. So this ordered pair, I think it helps to count if you label them. So 0, 2, and then this is at 6, 4. Those are 2 points I can use to help find the slope. So I'm going to count rise over run. I need to go up. That's up 2, and then over 1, 2, 3, 4, 5, 6. Up 2 over 6. So the slope of this line is 2 over 6, which reduces to 1/3. The slope of that line is 1/3. Let's look at this one. That's 0, -1, and 6, +1. So I need to go up 2 and over 1, 2, 3, 4, 5, 6. Also up 2 over 6, which reduces to 1/3. So the slopes of the lines are, one of them is 1/3 and the other one is 1/3. If you want to be fancy, you could say like M1 and M2, the slopes of the two lines. Determine the y-intercepts. The y-intercepts are 0, 2 and 0, -1. 0, 2 right here, that's where it hits the y-axis, and 0, -1, that's where it hits the y-axis. So what do you notice about the slopes of the line? They're the same. Okay, the slopes of the line are the same. What about the y-intercepts? Well, you could redraw this a lot of different ways. So what I'm going to do is just kind of sketch this and say, what if I took this same thing and I were to move it up or down? Do you think they would intersect still? I don't think so. So what I'm going to say is they are different, but what I'm really just making sure is that they are not the same. They are different. They are not the same y-intercept. If they were the same y-intercept, they'd have the same slope and the same y-intercept, they'd be the same line. So it is kind of noteworthy. They have the same slope, but they are different y-intercepts. So I should probably use better pronouns. I should say the slopes are the same, the y-intercepts are different. That's what parallel lines, what you can learn about parallel lines. They have the same slope and they have different y-intercepts. Let's try this guy. This is at -3, 6. This is at 0, 1. This is at -5, 1. And this is at 0, 4. So when I count my rise over run, I'll call this line 1, and I'll call this line 2. And we'll use some fancy notation. So M1 and M2. So line 1, if I count my slope, I'm going to count up 1, 2, 3 over 1, 2, 3, 4, 5. Up 3 over 5. So the slope of line 1 is 3/5. The slope of line 2, I need to go down 1, 2, 3, 4, down 5 over 1, 2, 3. So down 5 is -5, over 3 is -5/3. So I have the two slopes, and I'm going to look at them now, and we're going to say, okay, well, I should find the y-intercepts too. What are the y-intercepts? One of them is at 0, 1, and one of them is at 0, 4. So I'll say 0, 4 and 0, 1. What do you notice about the slopes of the line? They're not the same. 3/5 is not the same as -5/3, but there is a relationship between these two. So if you take 3/5 and you were to flip it, it would become 5/3. So they are reciprocals. That's part of it. They are reciprocals. 3/5, the reciprocal of 3/5 is 5/3. But there's something else going on. 3/5 is a positive number, and negative 5/3 is a negative. So they're not just reciprocals, they're actually opposite reciprocals. Opposite means one is positive, one is negative. It doesn't matter which one is which, they have different signs. One is positive and one is negative. And then what's true about the y-intercepts? Nothing important. It doesn't even have a question here because nothing is noteworthy when you're talking about perpendicular lines about the y-intercept. They can have different y-intercepts. Right now they have different, or they can have the same y-intercept. If I can move this, let's see if I can get it. There you go. I can move this along and look. Now they have the same y-intercept, but they're still perpendicular lines. They still have opposite reciprocal slopes. So the y-intercept really doesn't matter when you're talking about perpendicular lines. It can be anywhere. They can be the same, they can be different, it doesn't matter. All that does matter when you're talking about perpendicular lines is that they have opposite reciprocal slopes. So the two main ideas here are parallel lines have the same slope and different y-intercepts, and perpendicular lines have opposite reciprocal slopes and the y-intercepts don't matter. So that's it for kind of introing parallel and perpendicular lines. Hopefully that's helpful, and when we go through the notes, you got a little bit of a head start.